In this video, we are having a look at question 1 from the CIE November 2013, paper 43. Part I is asking us to show that the acceleration is -6. So the first thing I'm going to do is draw a quick diagram to see what's going on. As I don't know the mass of the particle, I'm just going to use W to represent the weight of the particle up the slope, and I've used R for the normal reaction force. Now I need to resolve W, so I have all my forces acting on the plane, parallel and perpendicular. So down my plane, I've got W sine alpha, and perpendicular to the plane, I've got W cos alpha, and I've also added friction, which is moving down the plane because the particle is moving up the plane. Now we're given sine alpha in the question, but we do need to work out cos alpha. We can do this with a quick right angle triangle and use cos alpha equals adjacent over hypotenuse. So now I'm ready to use my F equals ma to find my acceleration. So my force is down my plane. I've got a negative friction, and I've got a negative W sine alpha. I'm treating up the plane as positive, and this is equal to ma. Again, we don't know what m is. I've used W for the weight, so the mass will be the weight divided by gravity, and then that's multiplied by a. Now what I can do is, for my friction, I can use F equals mu R. So in this case, I'm going to have negative mu is a third, and R is the W cos alpha that I've got on my diagram. Now the first thing I can notice is that I can cancel through my W's and substitute in my cos alpha and my sine alpha, and then rearrange to get A. I've used G equals 10, so if we multiply by 10, we get A is equal to -6, which is what we needed. For part 2, we're going to use SUVAT. U is 5.4 from the question, V is 0 because it's when the particle stops moving, and A is what we worked out in part I. So I'm going to use V squared equals U squared plus 2AS and substitute these values in. Rearranging is going to give us S is equal to 2.43, and that is our distance.